you have different kinds of muscles. You have smooth muscles, and which are in your digestive tract, and then you have striated, and these are the ones which are both are highly innervated, but we're going to focus on these striated muscles. And you have these nerves that come in, and at the nerve, so these nerves are starting here in the ventral root. Well, it goes through the ventral root, from starting the ventral horn to the ventral root, and then synapses. This is the presynaptic cell here, and then this is the muscle here, and this is all those neurotransmitter receptors, very dense here, and then it actually thin out very deep in these invaginations. And you can actually see presynaptic. This is probably where you get a lot of the release here of the vesicles. So the neurotransmitter that's being released is called acetylcholine. And this specialized synapse is called the neuromuscular junction. And it's one of those things where if an action potential ends here, it jumps a tremendous amount of neurotransmitter to create a very reliable response in the muscle. Alpha motor neurons are the ones that are actually innervating this striate muscle. You have what's called a motor neuron pool, which is how many neurons are going to the same muscle. So each muscle will have a bunch of strands in it, and one neuron could innervate a whole bunch of muscle fibers, which means whenever that neuron fires, all those fibers contract. Or you could have a one-to-one. And so the higher the control you want in the precision of that contraction, the more neurons per muscle fiber you have. And in fact, things like the eye, you get almost a one-to-one muscle fiber to neuron. And when you stimulate, you'll get a slight contraction. And if you start stimulating slightly faster, these contractions will start to summate. And at some point, you stimulate really fast, and you pretty much get saturation. Increasing the firing rate of those neurons doesn't give you a stronger contraction.